I started the recording now. Okay. So in our last session, we started with deep learning and we saw the theoretical concept of deep learning. And what we understood was that in deep learning, we are trying to simulate the behavior of human brain. Now, human brain is made up of billions and billions of neurons. So this is a structure of a single neuron in our human brain, right? And these neurons are connected with another neurons, like you can see in these images. And one neuron takes some decision and passes the decision to the following neuron. And this decision is passed in the base of the electrical impulses, right? So here, the intensity of electrical impulse, right? It indicates the decisions for a particular action. So we try to simulate this in our computer world, and we get a deep neural network, which looks something like this. Right? It is actually a sequential layer. The first layer will become as an input layer. The last will become as an output layer, and rest of all the layers which are between input and output, we call it as a hidden layer. Now this is a basic neural network structure, right? Where we only have one hidden layer, one input layer, and one output layer. The structure can grow in a complex network, which looks like this. Like you can see here, there are multiple hidden layers, right? In between input and output layer. Now each of these hidden layers, so all of these green circles are nothing but as neurons, right? And these neurons from computer point of view, they are nothing but a mathematical functions. We call them as an activation functions. The activation functions takes the value from the previous layer, right? Then it applies the activation function and it passes the output to the next layer. Various activation functions which we saw in our last sessions were threshold function, sigmoidal function, rectifier function, and hyperbolic tangential function. Now neural network, how do neural network learn? Neural network learn with the concept of forward propagation and back propagation. Now in back propagation, what happens is we try to adjust the error by adjusting the weights, right? And how are we going to do this? With the help of a concept called as gradient descent or stochastic gradient descents. What are gradient descent and stochastic gradient descents? These are the approximation technique which help us to minimize the cost function. And finally, we ended up with the steps for building an artificial neural network. Now in our today's session, we will try to build an artificial neural network, right? We'll actually try to write a program for artificial neural network. And in order to do that, I told you that we need certain libraries, right? And I requested you guys to create, to install the libraries at your end. I hope everybody have done that. The different libraries which we need are TensorFlow and Keras. So these are the two important libraries which we'll be using. In fact, we are going to use Keras library, which in turn internally uses TensorFlow library. Right? And this is the place where we stopped last time. Is this clear, guys? What about Ashu? Perfect. So to implement the neural network, we are going to take the help of this following example. So this is a data set, and where each row in this data set represent one customer, right? So the use case here is, let's say there is a bank, right? Let's say there is a bank called as an ABC bank. And in this ABC bank, there are, like, let's say plenty of customers, right? And what the ABC bank has observed that from past 1 year, many people are leaving their bank. They are closing their account and they are moving out of their bank, and they're taking the service of some another bank. Now this is a loss for the bank, right? Do you guys agree with me on this point? Perfect, right? So now what we want to do is we want to analyze, right, our customers, and we want to understand why they are leaving our bank. Okay, So let's say if we write an intelligent program which will tell us in advance that there is a good probability that customer PQR, or let's say customer number 8, right, he might leave our bank. So if we get to know that knowledge well in advance, then what we can do is we can ask the relationship manager to give a call to this person, right? And we can ask him like, are you satisfied with our service? Is there something which we can do to improve it, right? So this is a proactive measures that we can take in order to improve the customer experience, and thus ensuring that customer doesn't leave our bank. Does the use case make sense? What about Ashu? Perfect. Now this is a clear example of classification technique. Do you guys agree? Here what we want to identify is, we want to identify whether a customer will leave the bank or he will not leave the bank. Do you guys agree on this point? Perfect. So yes, I can solve this problem with different classification techniques that we have learned, right? So we have learned logistic regression, we have learned decision tree classification, random forest classification, we have learned naive Bayes classification, right? We have also learned support vector machines classification. So you can apply any of that technique on this data set to get the output, right? But now what we are going to do is, instead of using our regular algorithms, we will try to solve this problem with the help of artificial neural network. Is this clear? Perfect. So let's see how to do that. So if you can see, we have here different various columns, right? We have row number, customer number, surname, credit score, geography, gender, age, tenure, balance, number of products, has credit card, is an active member, estimated salary. And the last column, exited, indicates whether a customer has left the bank or not. So what we have here is a historical data of last few, let's say 1 year, of all the customers, those who have left our bank as well as those who are still with us. Is this clear? Can you please confirm it on the chat window? Perfect. So let's see what are the different columns. So customer ID, surname. You will agree that these two columns will not help us to identify whether a particular customer is going to leave the bank or not going to leave the bank. Correct? Do you guys agree with me on this point? Similarly, row number, it's of no use to us. Let's see credit score. Yes, based on the credit score, a particular customer may leave the bank or may not leave the bank, right? For example, let's say if the credit score is very, very bad, right? If the credit score is very, very bad, that means that customer is defaulting in most of the cases, right? And if you realize, like most of the bank have a rule that you have to keep minimum balance of, let's say 5,000 rupees in your bank, right? But based on the credit score, if credit score is so bad that we can actually tell that this customer is going to default, right? In fact, he is defaulting at many places, and there is a huge probability that he will actually leave the bank. Why? Because he's not able to even maintain that 5,000 balance, right? So that's why he's deciding to close the account. Then let's talk about geography. Yeah, based on location, a person may decide to leave a bank. For example, if you take an example of Standard Chartered, right, you'll realize that the ATM of the Standard Chartered are very, very, less in number. So let's say if I'm having a card of a Standard Chartered bank, and if I'm not able to find an ATM of that Standard Chartered bank at my location, right, then it's obvious that I will leave that bank and I will go with other bank who is going to provide me that service at my area. Is this clear? Do you guys agree with me on this point? Ashu? Ashu, you there? Okay. I'll take the no reply as you have understood this and you agree with me. All right, let's move ahead. Similarly, based on gender, age, right, person may decide to leave the bank. For example, there are certain banks who has more preference to the female customers, right? They might give more interest rate to them, right? And if this current bank is not giving that interest rate to a particular female, right, then she may decide to close this account here and open an account at somewhere else. So yes, gender can be an factor whether a particular customer will leave a bank or not. Similarly, age. Let's say in case of senior citizen, if there is another bank who is giving a very good fixed deposit rate, right, at some other bank, as well as let's say saving interest rate at some other bank for the senior citizen, right, as compared to this bank which we are looking at, right, then there is a good probability that customer will leave this bank. Similarly, the tenure, right? So tenure indicates how long that particular customer is with this particular bank. Like for example, customer with row number 1, right? He has an account with this particular bank from last 2 years. Similarly, customer whose name is Onyo, right, has an account with this bank from last 8 years and so on. So tenure indicates how long that customer is with this bank. Now, tenure can also be an indicator whether he will leave the bank or not. Right? For example, if a customer is having an account, right, from last 8 years, that means I can actually conclude that he is happy with our service. Then there is very less probability that he will leave the bank. Right? Now let's talk about the balance. Yes, sometimes the balance can be an indicator. Right? If a person is maintaining a good balance within our bank, which means that he is happy with the services that we are providing. And if customer is maintaining a very, very bad balance consistently, then that can be an indicator that, you know, he is not happy with our bank. Is this clear, guys? Requesting you to please confirm. Perfect. Now let's talk about this column, number of products. So what number of product indicates is, let's say this particular bank provides a facility of credit card, right? And you can see that this particular person has taken that facility of credit card, right? So the credit card facility becomes as one product. Similarly, the same bank, let's say it provides a facility of, say, fixed deposit, right? And let's assume that this particular customer, Onyo, right, he has taken the credit card as well as fixed deposit from our bank, right? So the number of products will be here 2. Let's say he takes another product, let's say some investment scheme from this particular bank, right? Let's say he has taken a loan, right? Then that also becomes a product. So you can see here the number of product indicates how many number of facilities that this particular customer has taken or products he has taken from our bank. And products can be your credit card, fixed deposit, a loan, etc. So if a customer has taken a lot of products from our bank, which means he's happy with our service, right? He's actually happy with our different product schemes that are available. So that's an indicator that he may not leave a bank. But if products are very, very less, then there is an indicator which indicates that he might not be happy with the rest of our service, right? So there is a huge chance that he will leave our bank. Is this clear, guys? Perfect. Next column has a credit card. That can also be an indicator, right? So here I can conclude the product which this person has taken, one, is nothing but the credit card facility, right? Here you can see he has taken some different product, but he doesn't have a credit card. You can see this person, he has number of products 3, and also he has a credit card. So one of the product which is here, right, is a credit card, and so on. So has credit card can also be a good indicator, right? Why? Because let's say our credit card is giving a very nice service. It's giving very huge discount points and all that offer, right? That case, that person might choose to stick with our bank, right? So yes, this particular indicator has credit card can help us to decide whether a person will leave a bank or will not leave a bank. Now let's talk about next column, is active member. Now what this is active member indicates whether a person is actively using our bank services or not. Let's say, for example, I have withdrawn, let's say, some 5,000 rupees from my bank with the help of debit card, right? Let's say I did that in last week. So then, yes, I can be treated as an active member. Let's say I haven't used any service of this bank, let's say from last 7-8 months, right? Then I can term as that this particular member is not an active member. So this active member definition may vary from bank to bank, right? Let's say in this particular case, we are saying if a person has used the facility in last 2 weeks, we term it as active member. If the person have not used any of our facilities from last 2 weeks, then we will treat him that he is not an active member. Is this clear? What active member indicates? Whether he is using our facilities or whether he is not using our facility. Can you guys please confirm it on the chat window? Maithili? Yeah. So what I was saying this is active member. What this column indicates whether a customer is actively using our service or not. Right? And this definition may vary from bank to bank. Right? And what the definition can be is can be as simple definition as, let's say, if a particular customer has say withdrawn some money from our bank from, let's say, in last 2 weeks, then we will term him as an active member. Or if a particular customer have deposited some money in last 2 weeks, then we will still term him as a active member. Right? It can be as simple definition as this. Indirectly, what this column is saying, whether this particular customer is actively using our service or he is not using our service. If he is active, which means he is happy with our service. If he is not active, that means he is not happy with our service. So we can get such kind of indication with the help of this flag. All right. Then let's talk about the last column, that is estimated salary. Right? Now, this is an estimated salary. Your bank may not know your exact salary, but based on the balance which you maintain, right, they can predict what will be the estimated salary of this person. Few of the customers might have actually a salary account with this bank. In that case, the estimated salary number will be almost accurate. But those who don't have a salary account, they just have a saving account, right? What this bank can do is they can estimate, like they can predict what a rough salary will be, and then they populate it over here. And the last column, exited. So this column indicates whether a customer has left the bank or not. Right? This is a historical data, like I mentioned it earlier, of last 1 year, right? And it includes data of both the types of customer who have left the bank as well as who still are present in our bank. And exit column indicates whether the particular customer has left the bank or not. So you can see here this particular first customer, right? He is actually in fact an active member, but he has exited the bank. Don't get surprised. What this we can conclude from here is that, let's say he has just closed the account. He has closed the account in this last 2 weeks where he has also withdrawn the balance. So yes, this is a valid scenario where he can be an active and he has exited. It indicates that in last 2 weeks, he has closed the account. You can see here in this case, right? He has decided to exit the bank and he is not an active member. Is this clear, guys? Perfect. So in our case, the columns which we'll need to decide whether a particular customer will leave the bank or will not leave the bank is from column D, that is from credit score, till estimated salary, that is column M. Is that clear, guys? Can you please confirm it on the chat window? Perfect. So let's now look at the code. Let me zoom this. Let me clear this console and let me remove all the variables. Now the first step which we are going to do is we are going to set our working directory. So I have set my working directory to deep learning folder and artificial neural network. So this is going to be working directory. In this, we are going to read the file called as churn modeling.csv. And that we are going to do with the help of pandas library, right? So our first line will be import pandas as PD, read CSV, name of the file. So let me execute this 2 lines of codes, select and control enter. I'll go to my variable explorer and you can see we have successfully read the data. So we have almost 10,000 customers informations. Right, so these are the information of 10,000 customers. We need in our variable X start column index number 3, right? So this is 0, 1, 2, and 3. So starting from column index 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We need to read all of this information into our variable X. And the last column index 14 will be our variable Y. So let us divide that. So dataset.iloc, that is I location, right? Reading all rows of columns starting from 3 till 13. So this 13 is exclusive. Similarly, Y dataset.ilocation starting with 13 till 14, and 14 is exclusive. In fact, let me do a count it again. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So the indexes looks good. Let me execute this now. Select, control enter. So now I have variable X. I also have variable Y. Now observe your variable X. So let me do this. Right now it's an object, right? If I double click, it will not allow me to view it. If I simply type here variable X, right, you can see the data here. It is a mix of both numbers as well as text, right? So let's go back to data set. So the text information which we have is geography and gender, right? And rest all of them are numbers. So first thing which we are going to do is a simple imputer to handle the missing data. Luckily in this data set, there is no missing value. So here 0 doesn't mean it's a missing value, right? It means that the balance itself is 0. So even if you don't apply your simple imputer step, it's still fine. But we'll still have to handle column index, that is 0, 1, 2, 3, 4, and 5, right? You need to handle column index 4 and 5 of data set. In your variable X, that will be index 1 and 2, right? So your variable X starts from credit score, right? So credit score becomes index 0 in variable X. Index 1 will be geography and index 2 will be gender. You'll have to handle this. And how to do that? With the help of label encoder and one-hot encoder. Is this clear, guys? Can you please confirm it on the chat window? Oops. Perfect. So let us apply label encoding. Before that, I'll suggest you guys to please write the code for imputer step. It's always better you perform this imputer step, right? Even if we know that the data is not missing. So I'll leave that part to you guys as a homework. Okay, so let's import the library of label encoder. Select Control Enter. Then we'll create the object of label encoder. Now we are going to apply we are going to apply label encoder for index 1, which is country. So you can see here, I am creating a variable called as label encoder on variable X for index 1, right? Similarly, when I'm going to apply label encoder on the gender column, which is index 2, I'll use a different variable altogether. I'm not going to use this one. Why? Because here the label encoding will happen according to the data present in the country column. Let's say if 0 has been assigned to France, 1 has been assigned to Spain, right? Here 0 might be assigned to female and 1 might be assigned to male. So we don't want that confusion to happen here, right? So that's why we'll use a separate variable altogether. So let me select this and execute it. Select Control Enter. Is this step clear, guys? What about others? Ashu, Amay? Perfect. Thanks for confirming. Now let's check our variable X. So we have successfully applied label encoding, right? So now we have all text, all numerical data. But as soon as we applied label encoding, right, the problem started over here with column index 1, which is country. Now all of a sudden we are saying here, and we can conclude that 2 is greater than 0, right? But before applying label encoder, we were not able to do the comparison between the country. We cannot say Spain is greater than France and so on, right? So because of label encoder, the comparison have kicked in, which we want to avoid. And how to avoid that? With the help of one-hot encoder. So let's do that. I'm going to use now one-hot encoding technique to encode column index 1. See, we'll not apply one-hot encoding on column index 2. Why? Because column index 2 in your variable X is nothing but gender. And there are only 2 genders here, male and female. So 0 and 1. Right? So here, even if you don't apply one-hot encoding, it's still fine. Is that clear, guys? Requesting everyone to please confirm. Perfect. So let's apply one-hot encoding on column index 1 of variable X. So import the library, select Control Enter, create the object, mention here the column index 1, indicating that we are going to apply one-hot encoder on column index 1. Select Control Enter, and then finally fit and transform and convert it into an array. So now you can see I got variable X. Right, the first 3 columns, right, they are from country, right? But you can see we have immediately avoided, we have to also avoid the dummy value trap, right? So I have to ignore the column index 0. So I'll select and I'll hit enter. And now I get a proper output. Is this clear? Okay, a quick question to you guys. Why are we ignoring the column index 0 after applying one-hot encoding? So Ashu is saying dummy value. What about others? Amay, Maithili? Okay. That's right. The proper way to put this up is, because of one-hot encoding, there is an implicit duplication of data. Right? And to avoid the duplication, we are removing the index 0. All right. So now looks like my data is in correct format. But before that, don't forget to apply standard scaler. Right? You can see here, this data is in terms of whether country is present or not. This is a credit score. This again is gender. This is an age. This is number of products. This is a balance and so on, right? So here, each and every column are at different level. We need to bring them at the same level, right? Same scaling. So we'll apply feature scaling for this. And the best feature scaling which we apply is standard scaler. So import the library, create the object and apply fit and transform. And now you can see all the columns are at the same level. Now let's divide our data in two parts, that is training set and test set. So this variable x and y, we will divide it into two parts, training set and test set. Using training set, we will create the artificial neural network, right? And for verification purpose, we'll apply that artificial neural network model created on the test data. Let me select this and hit Control Enter. Done. So at this, we have finished our first part, which was data pre-processing. Any doubt till this point, guys? Yeah, thanks for confirming. Perfect. Let's move. Now we'll start with artificial neural network. Now, as I mentioned in our last session, we are going to use a library called as a Keras, right? And also our ANN, you can see this diagram of artificial neural network, right? I told you it's a sequential, right? The output of this neuron will be given as an input to the next neuron. And similarly, the input for this layer is actually the output from the previous layer, right? So it's a sequential model. I mean, this neuron will not get activated unless and until it receives input from its previous layer, right? So each layer depends on its previous layer. So it's a sequential model, right? So using Keras library, first what we have to do is, let me open an Excel file. And I'll close this one. Or let it be. Right. So using Keras library, what I need is a sequential layer, right? So this entire box, you can consider it's a sequential framework. All right. And for this, Keras has already have a library called as a sequential. All we have to do is just create the object of sequential. That's it. So with this step, our sequential machine learning model is ready. Inside this sequential layer, now we will start adding one layer at a time. We will add an input layer, right? So inside the sequential model, what are we going to add is first is an input layer, right? Then we will add multiple hidden layers. So we keep on adding layers like this. Right? And finally, after adding some hidden layers, we add an output layer. Let me just use a different color so that we can distinguish between input layer and output layer and hidden layer as well. Right? So this cream color will indicate, consider this as an input layer. This green color will consider as an output layer. Right? And this all blue colors are nothing but the hidden layer. Right? So what we do, we use a sequential object to create this layer, and inside this layer, our next job is to add these individual layers. Is this clear, guys? Can you please confirm it on the chat window? Perfect. So in order to add this multiple layers inside the sequential model, we have a library called as a dense. Right? So Keras has a library called as a dense. So dense allows us to add those different layers. Right? So you can see here we have D1, D2, D3. What this means is we have added 3 layers. Right? We have added D1, we have added D2, and we have added D3. Is this clear? In fact, this D3, it's actually an output layer for us, right? So what we have is this structure. Input layer, D1, D2, and D3. Can you guys please confirm it on the chat window? Okay. So for that, we create the object of dense. Don't worry about this. We will address them shortly. Right? So we create D1, then similarly we'll create D2, and similarly we'll create D3. Right? And we need to add this D1, D2, D3 inside the sequential object, which was classifier. So you can see here classifier.add D1, classifier.add D2, and classifier.add D3. Is this step clear? That's based on trial and error, Maithili. There is no right answer to this. It's a research and development part, right? So you have to keep on trying different number of hidden layers with different number of activation functions, right? And so on. Perfect. All right. Now let's take a further look. So inside this, we need to mention how many number of neurons are there, right? Inside this D1, we'll have to mention number of neurons. We'll also have to mention activation functions used by those neurons, right? And so on. Similarly here, we have to mention number of neurons, activation function used. Same thing here as well, right? And for that, we have to put those as a parameterize inside the dense. So let's do this. We will go to our help section and we'll take a look at the help for the dense function. So we'll say keras, K-E-R-A-S dot layers dot dense with D capital. Hit enter. And you can see it has given me the documentation for dense. Let's scroll down. So the argument used inside this are, I think, activation, input, and output. Input shape, output shape, and what is the activation function to be used. Right, so these are the arguments used inside this. So you can see here, input shape. So here you can see dense function, some number, input shape, and so on, right? So you can see here, if I have also given the comments, if you write it in this fashion, here the 32 becomes the output and 16 becomes the input, right? So we need to add those dense layer here. And in the next one, again, we're doing model.add. Here, dense is having 32. So what this means is, again, the output will be 32, right? So we have to mention the same thing for this dense function as well. Now for D1, well, let's go back to the Excel. For D1, it is going to take the input from the input list, right? It is going to take the input from the input list. How many columns do we have in the input variable X? Let's go to variable explorer. So X is having 11 columns. So what does this mean is, for D1, the input shape, like let's go to help file, right? So here, input underscore shape for D1 will be 11. Is this clear, guys? Can you please confirm it on the chat window? So for D1, the input shape is going to be 11. Okay. See here, Maithili, D1 is going to take the input from the input list. Do you agree with me on this point? And how many columns do we have on input layer? So your input layer is nothing but your variable X. Number of columns in variable X is 11. Right? So therefore, the input shape for D1 is 11. Right? So this input shape indicates from how many neuron it is going to receive the inputs. Right? So this individual neuron here. Right? So this is our D1. Each neuron which is available in D1, it receives the input. How many inputs? 1, 2, 3, and 4. 4 inputs, right? So input shape for D1 is 4 in this diagram. Is this clear? Perfect. Let's move on. So let me just undo this. So you can clearly see in D1 under the dense, right? Input underscore dimension, we have put it as 11. Right? So the parameter name is input dimension for input shape. Is this clear, guys? What about Ashu? Don't go to the output yet. Just focus on the input dimension. So is input dimension equal to 11 clear? Perfect. All right. So we have decided input, right? Input for D1, which is 11. Now let's decide on the activation function. What are the different activation functions available? Sigmoidal, threshold, rectifier, hyperbolic, right? So you can use any of this. Now the activation function, once it has been used in a layer, it is common for all the neurons in that layer, right? So right now, let's say we have decided that for layer D1, activation function is a rectifier. Then all the neurons which are inside this D1 will have rectifier activation function. Let's say instead of rectifier, we decided to keep it as sigmoidal. Then all the neurons which are in this layer D1 will have a sigmoidal activation function. So if I try to explain it using this diagram, let's say if I decided for D1 to use rectifier activation function, all of these neurons will use same rectifier function. Is this clear? See, in this particular model, you cannot have different activation functions for different neurons in the same layer. A given layer will always have same activation function. Is this clear, Ashu? Perfect. And we can indicate that with the help of activation. So activation is equal to ReLU. ReLU means rectifier function. Similarly, other rectifier activation functions are sigmoidal and so on. Right. So we have decided activation function for our D1. We have also decided input number of inputs, right, for D1. Now the remaining things which we have to decide is this particular layer D1, right? Let's say after calculating the intensity, right? It is going to pass the intensity to the next layer, right? So let me put it here and let me put this here. So it will pass the output from this layer to next layer, right? Let's say in this D1, we have, let's say, total number of neurons as 5. Sorry, not 5. In this case, it is going to be 11, right? Because there are 11 input layers, right? 11 neurons in the input or 11 columns in the input layer. Therefore, D1 will automatically have 11 neurons in it. Is this clear, guys? The number of neurons in D1, it is automatically going to be 11. Why? Because it is going to receive data from 11 inputs, right? So here we see this input dimension 11 itself indicates total number of neurons available in D1. So your diagram here will have 11 neurons, right? And each neuron is going to give its intensity to the next layer neuron. Now we have to decide this neuron, right? How many, sorry, the output of this neuron, right, will be passed to how many neurons in the next layer. And that's what this output dimension indicates. So output dimension 6, what it's telling us is that in our neural network, right, we have 11 neurons here. And in the next layer, automatically there are going to be 6 neurons. Now, why 6? Again, there is no fixed answer. You have to keep on doing trial and error. You start with some odd number, 5, 7, 9, 11, and so on. And you keep on increasing the number of neurons. Is this clear, guys? Am I, Asho? So I think, Asho, that answer your question. Output dimension as 6, right? Can you please confirm it on the chat window? Perfect. So let me try to do it in this way. Let's say this is neuron 1, neuron 2, neuron 3, neuron 4, neuron 5, neuron 6, neuron 7, neuron 8, neuron 9, 10, and neuron 11. And this is input 1, input 2. Let me see if it takes an auto increment. Yes. Input 3, 4, 5, 6, 7, 8, 9, 10, 11. Now what has happened is input 1 will go to neuron 1. Input 2 will go to neuron 1. Input 3 will also go to neuron 1 and so on. Similarly, input 1 will also go to neuron 2. Input 1 will also go to the neuron 3. Input 1 will also go to the neuron 4 and so on. Is this clear? Then we have said output dimension for layer 1 is 6. So the output dimension of previous layer indicates total number of neurons in the next layer. So here we will have 6 neurons, right? So we'll say hidden layer, neuron 1, hidden layer, neuron 2, hidden layer, neuron 3, hidden layer, neuron 4, hidden layer, neuron 5, hidden layer, neuron 6. Right now, the output of N1, whatever is the output of N1, will go to all 6 neurons of the next layer. Right? And this becomes as an input for neuron 1. Similarly, output of neuron 1 will also go to the next layer's neuron 2. So this becomes input for next layer's neuron 2. This next layer neuron is going to receive inputs from all of the neurons, right? So what does it means is HN1 will also receive input from neuron 2 of previous layer. HN1 will also receive input from neuron 3 of previous layer, and so on. Slowly, you will get a structure which looks like this. Is this clear, guys? Ashu, can you please confirm it? Yeah, we'll come to that point, how it is going to get processed. But is the structure clear, how the structure is forming? Perfect. So you can see output dimension 6, this is clear. Now init. So if you remember in our last session, I told you in the beginning, we assign equal weightages to all of these edges, right? In fact, that is our first step as well. Initialize some weights, right? And how do we initialize? We initialize them with the function called as uniform. So in the beginning, each of these edges will have uniform weights. So is this init function, init clear? Init parameter clear? Perfect. So what we have defined so far is a structure called D1, this layer, which is having 11 neurons. Why? Because total number of input dimensions are 11, right? And we are saying output dimension for layer 1, that is D1, is 6. So indirectly, we are deciding the total number of neurons in D2. Right? So a structure has been created like this so far. Now we will add definitions for D2. So here in D2, we are saying D2 is a dense layer whose output dimension is again 6. So what does it indicating is the next layer will also have 6 neurons, right? So hidden neuron N1, N2, N3, N4, N5, N6. Initialize the weights uniformly. And activation function uses rectifier. So this D2 will also use rectifier as its activation function and uniform weightages. And the output dimension for D2 is 6. Correct? So we have mentioned output dimension for D2 is 6. So which means there are 6 neurons here. So this becomes our D3. Is this clear? And again, the connection will be similar. The output of HN1 will go to N1, N2, N3, N4, N5, and N6 of D3. The output of HN2 will go as an input to N1, N2, N3, N4, N5, N6 of D3. The output of HN3 will go as an input to N1, N2, N3, N4, N5, N6 of D3, and so on. Now we will start defining D3. So we are saying create another layer called D3, which is a dense layer, whose output dimension is 1. So what does it mean is the output of D3 is 1. So there is only 1 here. Then we are saying initialize the weights uniformly, and activation function used is sigmoidal, right? So here the activation function will be sigmoidal. So not here, here. right? And N1 will receive the inputs from N1, N2, N3, N4, N5, and N6 of D3. And then finally, N will give us the final result, which is going to be our prediction. Is this clear? Perfect. Guys, just a second. I think this should be here. This is correct. So let me select this, hit Control Enter, create it. Let me add these dense layers inside the sequential model. Select, Control Enter, done. So now we have a framework ready, right? Where we have added the input layers, we have added different D1, D2, D3 inside the sequential model and so on. Now, when we say classifier.compile, right? If you see here, let's go to the step. That is forward propagation and back propagation. So we need to make this neural network ready, right? So for that, we use this compile. And in the compile method, we mention what are we trying to do, right? So here we are saying we want to optimize the binary cost entropy. What is binary cost entropy? This is this cost function. We want to optimize this cost function, right? So we are mentioning that cost lost function or cost function uses this, right? And we are going to optimize using Adam. So this Adam is nothing but your gradient descent, right? And what are we focusing on? We are trying to improve the accuracy of our model. So that's why we mentioned metrics as accuracy. So this compile just connects each and every. So this lines, which I was drawing it manually, right? This is what compile does. It informs that, listen, the final, right, in the back propagations, we are going to back propagate the error function, and the error function uses binary cross entropy. That is half of actual minus predicted square, right? Is this clear, guys? What compile is going to do? So we'll get a cost function which is in this format, and we want to optimize this. So to optimize this, we'll be using gradient descent technique, which we have again mentioned it in the compile method. So till this point, we have just created a framework for our artificial neural network, right? Your program has not started learning yet. In order to do that, we will say fit. So fit method is to what? To train, to learn, right? And in the fit method, we are passing training data of X value and its equivalent Y value. Now batch size 3. What batch size 3 is indicating is that I will adjust the weights after processing 3 inputs or after processing the 3 rows. So if you recollect this slide, right? Batch and stochastic. So here batch size was 8, right? So the weights were updated after processing 8 rows. Here it's 1, which goes back to stochastic gradient descent. Therefore, after each and every row, the weights were getting updated. And again, there is no right way to do this. You have to do trial and error only to come up with the answer. Is this clear? And number of epochs. What this number of epochs means? That I am going to learn on this data 2 times. Means, let's go to variable explorer. So overall we have 10,000 rows, right? In your variable X test, overall we have 2000, and in Xtrain we have 8,000, right? So overall we have 8,000 rows. Right? So this neural network will learn on this 8,000 rows 2 times at a batch size of 3, right? So after processing 2,666 rows, it will update the weights. Then it will again process, sorry, not my bad. After processing 3 rows, it will update the weights. Then again after processing next 3 rows, it will update the weights. Again after processing next 3 rows, it will update the weight, and so on. So for in the first attempt of 8,000 data, this many times the weightage will be updated. Now we have mentioned number of epoch as 2. So what will happen? Again, it will process on this 8,000 rows to learn, right? So total number of times your weightages that are going to be existed are this into 2. That is approximately 5,333 times. Is this clear what number of epoch means? How many times you are going to give this data set, or you're going to ask your neural network to learn. So it's like learning it first time and second time again doing a kind of revision. Is this clear? Can you guys please confirm it on the chat window? Perfect. If you increase number of epochs, let's say 3, 4, 5, 6, 7, 8, 9, 10, and so on, your accuracy will also get adjusted. Similarly, based on the changes in the batch size, again your accuracy will get adjusted. So let's try this. So now I'm going to execute these 2 lines of code. That is first to compile the model, select, Control Enter, and then to learn. Now just observe the output here. When I am learning, select, Control Enter, you can see, right? It is processing 8,000 rows at a batches of 3. Each time it is adjusting the weightages, right? Adjusting the weightages will give me the loss function and the accuracy. See, after processing 8,000 rows, again it will process the 8,000 rows. So this is the second epoch. And finally, you can see at the end of the second epoch, the accuracy that we are getting is 81% on the training data. Is this clear, guys? Requesting you to please confirm. Perfect. And last, after learning, we need to apply it to the new data set. So as a new data set, we are considering X test variable, right? So we'll simply create a predict function. We'll pass that variable in a predict function. Select, Control Enter. And finally, we got the predicted values. Now, since we have used sigmoidal function as the output, right? You can see in your D3, the activation function was sigmoidal. So output is going to range between 0 to 1. So what this indicates is the percentage probability. There is a 28% chance that he will leave the bank. There is a 30% chance that he will leave the bank, 35%. There is a very, very less probability, like almost 0.9, right? Less than 1% that he will leave the bank, and so on. And now let's compare them with the actual values which we have it in our Y test. Now your Y test is having only zeros and 1. Y prediction is in the form of percentage, right? So here we can put some threshold. Let's say above 40%, we will consider that he will leave the bank, right? So you can have that kind of threshold. So here, so all you have to do is YPRED greater than 0.4. So that will be, if it is above 40%, he will leave the bank. If he is less than 40%, he will not leave the bank, right? Why we are keeping 40%? Again, it depends upon the individual choice, right? Sometimes you want to become more proactive, right? So you will consider anything above 40% is slightly dangerous. Anything above 30% is less dangerous, right? And so on. So you can have that threshold accordingly. So let us use 40%, anything above 40%. is a good probability that he will leave the bank. So let me just select this, run it. And now you can see your Y prediction is also in terms of zeros and ones. So true and false, right? True means he will leave the bank and one means he will not leave the bank. And then finally, you'll put that in the confusion matrix, select, control enter, and you will have your confusion matrix ready. And now you can calculate the accuracy based on the test data, right? So here accuracy will be what? 1474 plus 186 divide by total number of rows in training set, that is 8,000. Okay, 1 second. Sorry, not 8,000, 2,000 because test data, right? So you can see the accuracy is 83%, which is close to what it has learned. Is this clear? Requesting everyone to please confirm. Perfect. Any questions related to artificial neural network program? Requesting everyone to please reply on the chat window. Maithili, am I? So you mean to see visualize in this form? Which output? So here our output is variable ypred. Y test is the actual values for an input X test. You mean to say in graph? Yes, you can apply graph here as well. You can definitely apply scatter plot graph here. So this was all our artificial neural network program. So as an assignment, what you guys are going to do is you're going to use all of your classification technique which you have learned on the same data set, churn modeling, right? You'll use it on the same data set and check its accuracy and compare it with the accuracy of your artificial neural network. Is this clear? Also, as a second assignment, try different number of neurons, hidden layer, right? Number of hidden layer, number of neurons, and different activation functions. And then check its accuracy. Is this clear, guys? Perfect. All right, let's do this. We'll take a break now for let's say 10 minutes. We'll sync up again at 1:30. Is this fine? We'll take a break of 10 minutes. We'll sync up again at 1:30, and at 1:30 we'll start with convolution neural network theory. Right? I'll stop this screen sharing and I'll also stop the recording. And I'll give you a new link once we are back at 1:30.